Today we're going to go over a brief overview of the chain rule, product rule, and the quotient rule. Kind of do a brief overview of them, go into a couple of examples, and essentially give a brief overview if you've forgotten any of these from your calculus or you're just now learning these. So we're going to go ahead and start with the chain rule. So when you take a normal derivative, say the derivative with respect to x of x squared, we can do that right out. We can go ahead and use the power rule, and we end up with 2x. And that's fairly straightforward. It's an easy thing to do. When we run into issues is when we try to do, let's say, the derivative with respect to x of, x plus x squared, all raised to the 1/2 power. You have a little bit of a, issue there. It gets a little bit harder. So what we end up saying is we're going to do essentially two derivatives. We're going to call this whole section right here essentially u, just to replace the entire thing. We're going to go and take the derivative of that. So we're going to go ahead and take the derivative, dx, or d, instead now u, of u to the 1/2 power. Makes it a lot easier. So then we're going to end up with 1 over 2 u to negative 1 over 2 du dx. So now that we have this part of it, we know that we can go ahead and evaluate the u portion of it. So we're going to then get inside of the derivative and go ahead and take that part. So du dx actually equals d dx of everything that we had inside, which is what we call u, x plus x squared. We can go ahead and evaluate that, and that's going to be 1 plus 2x. So we have everything inside of u, and we have u to the negative 1/2, and we have everything in front. So we're going to plug this portion of it in right here, what we evaluated du dx for, right into du dx. And we're also going to plug what we said u was into our substitution. So we're going to end up ultimately saying that dx of x plus x squared raised to the 1/2 is equal to our 1/2, which we got from the u sub, times u, which is all of that part, so x plus x squared raised to the negative 1/2 power, times du dx, which we evaluated to be 1 plus 2x. And so that is your final answer. All right, there, let me throw a box around that real quick. So the derivative right here ends up coming all the way down to equaling this right here. So that's our u substitution, and you can use it actually going the reverse direction for an integration, and that's kind of a later thing that you'll get to learn later. But if this is the way that you think about a chain rule as a u substitution, doing it for the integration makes it a lot easier. So definitely remember that going forward. Let me go and clear this for you so we can make some room for the product rule. Alright, so now for the product rule, we're going to start off saying that we have something a little bit more challenging. We're going to start out with x squared times the natural log of x. So to take a derivative of that outright wouldn't be very straightforward. So what we're going to do is we're going to go ahead and break it up into the product rule. And we know that derivative with respect to x of f of x times g of x equals, this is where you have to be very careful, f of x times g dx plus g of x times d f of x dx. So we'll go ahead and get into our example, but this is the general format of how you're going to end up doing it. So derivative with respect to x of x squared times natural log of x. So we're going to break that down. We know that derivative with respect to x of x squared equals 2x. We know the derivative with respect to x of ln of x equals 1 over x. So we're going to go ahead and work these two into our final solution. So we're going to start with the first part, f of x, which we're going to call our x squared, and then g of x is our ln of x. So doing the first part, we're going to do x squared, which is our f of x, times derivative of g of x, which is 1 over x, plus, and we end up with now the g of x, which is our ln of x, times derivative of x squared, which is 2x. So we end up, that simplifies down to x plus ln of x times 2x. That's your final answer. So essentially, it's going to be a formula that you're going to want to remember. An even simpler way to write this would be fx g prime of x plus g of x f prime of x. And that's a good way to remember it. For the product rule, you're always going to be adding. With the quotient rule, it gets a little bit more complicated. We're going to get to that. Alright, so moving on to the quotient rule, which actually is simply a extension of the product rule, and we'll get to that. So the quotient rule, we're going to say is derivative with respect to x of, let's do f of x over g of x equals g of x fx prime minus f of x derivative, or say g prime of x over g of x squared. Alright, so let's just see how that works out. If we have, let's go ahead and say derivative with respect to x of, let's go ahead and do 1 over x. Nah, let's not do that. Let's do x cubed over sine x. Alright, so we could go ahead and break this, into something a little bit more complicated, and try to, work it out using the product rule. We're not going to do that right now. We're going to start out just saying that we're going to use the quotient rule. So we're going to go ahead and say x cubed is f of x, and sine of x is g of x. And so g of x sine x times f prime x, 3x squared, minus x cubed times derivative of sine, cosine of x, all over sine x squared. Or we can say sine squared x. So that's what it breaks down to. So you don't have to really think about it. It's a fairly straightforward solution, and it just kind of falls out using this formula. You just got to remember bottom times derivative of top minus top times derivative of bottom all over the bottom squared. So say that to yourself several times. Make sure you remember it, because when you're doing it, you're going to have a hard time remembering it. So always remember the order that everything goes in. And if you end up forgetting, you can use the product rule and the chain rule. The combination of these two ends up giving you the quotient rule. So we're going to go ahead and see how that all kind of comes together. So let's do the same derivative. So dx of x cubed over sine of x. So we're going to take all of this, and we're going to go ahead and take the derivative of it using both the chain rule and the product rule. So we're going to change sine x into saying sine x to the negative 1 power. So dx of x cubed times sine of x to negative 1 power. So you see I haven't changed anything. Essentially, you've just put the sign to the top and put it in the -1 power. So now I'm going to do the product rule and the chain rule. So if you remember, product rule is that we have derivative of x of f of x g prime x plus g of x f prime x. So remember this ends up being true. So derivative with respect to x of fx times g of x, right out room here, equals this. So remember that. So we're going to go ahead and take the first thing, x cubed times the derivative of the second thing. So we know we can't take the derivative of sine of the -1, but we can do the product, or use the chain rule and say that sine is our u, take the derivative of u, and then figure out what du is, and take the product of those two things. So we'll do that separately. So derivative with respect to x of sine x to -1. So we're going to say that this whole part is u, and we're going to take the derivative of u to the -1 power. So that is going to end up being negative of sine x to -2 times du dx. Du dx is just going to be cosine. So we're going to end up with negative sine x to -2 times cosine x. Alright, so we end up with that. We're going to go ahead and work that back into our solution. So we're going to say we have negative sine x minus 2 times cosine x. I'll plug that in there. Alright, so we're going to add that. We have sine of x times the derivative of this, which is going to be our 3x squared. Okay, so we know that we have the portion sine of the negative x, which is our g of x times f prime x. We have sine x to -1, which we can actually rewrite as, so sine x to -1. We can also say is sine x over sine x squared. So we're going to plug that in right here. If you look, you can see actually we have that part there and that part there. So we're going to rewrite this in terms of x cubed times cosine of x over, this is sine x to the -2 from what we got over here, negative sine x squared. So we put it in the denominator to get rid of the negative sign in the power. Then we're going to have 3x squared times, we're rewriting this sign in the -1 as sine x over sine squared. So sine x over sine x squared. We can actually put these together. I don't know why I added a negative sign. Put these together. We're going to flip them so that the positive one is on the left and the negative one is on the right. So we're going to end up with 3x squared sine x minus x cubed cosine of x over sine x squared. So if you compare, you'll actually find that this solution right here is the same as the solution we got over here, as long as you didn't make any mistakes. So you actually kind of get to see that you can use chain rule and the product rule if you forget what the quotient rule is, but the work is a little bit more messy than just going straight to the quotient rule. So if you can remember the quotient rule, use that. If not, as long as you can remember these two, you're going to be good to go one way or another. And that's about it. Thank you so much.